Hi there, in this video I will present our paper MOS towards scaling out-of-distribution detection for large semantic space. I'm Ray. This work is done with Professor Sharon Lee at UW-Madison. First, let me give a brief introduction on out-of-distribution detection. In a closed-world setting, we always assume training and testing distributions match with each other. However, this is far from the truth when we deploy our model in an open-world setting, where training and testing distributions can differ a lot. In this case, if the test image is something the model has never seen before, we want the model to be able to decide this is an out-of-distribution image and I cannot make any prediction for this image. Therefore, in OD detection, the key question we want to answer is how to build machine learning models that function reliably in an open world. This is especially important for safety-critical applications such as medical treatment and autonomous driving. Because this is a very important problem, there already exists many works on OD detection. What we list here is only a tiny fraction of them. However, existing approaches are mainly driven by small-scale datasets such as CIFAR and MNIST. They contain very few classes, and the image resolution is also very low. However, in real applications such as autonomous driving, systems will perceive images from much larger semantic space with much higher resolution. What will happen in real world? How do existing approaches perform in a large-scale setting? In order to answer these questions, in this work we provide a new OD detection benchmark in large semantic space. We use ImageNet 1K as in-distribution data, which is more realistic and challenging compared to the previous CIFAR settings. We curate 4 out-of-distribution datasets from existing image databases. All images are high-resolution real-world images. We manually select concepts that are not overlapped with ImageNet 1K for OD evaluation, and we have made our benchmark publicly available. Next, we evaluate existing approaches on this large-scale benchmark. Specifically, we want to explore the effect of label space on OD detection performance. We randomly sample subsets of classes from ImageNet 1K and evaluate the performance of a common baseline MSP. As the number of classes increases from 50 to 1000, we observe that the FPR can rise quickly from 20% to 80%. Therefore, the important question we want to solve in this paper is how to perform effective OD detection on this large semantic space. We propose MOS, a group-based OD detection framework that scales well for large semantic space. Our key idea is to decompose a large semantic space into smaller groups, which will simplify the decision boundary between in-distribution and out-of-distribution data. For each group, a category others is added. An OD image will be mapped to others for all groups. However, for an in-distribution image, it will be mapped to some valid classes in the group it belongs to. And finally, the minimum score on category others among all groups, termed as MOS, will be used for OD detection. We compare MOS with existing approaches. MOS established a new state-of-the-art performance, reducing the average FPR by 14% compared to the best baseline. In conclusion, existing OD detection approaches do not scale well for large semantic space. In our paper, we provide a new OD evaluation benchmark targeted at large semantic space. We propose MOS, a group-based OD detection framework which achieves a state-of-the-art performance. We hope our research can raise more attention to OD detection in a large-scale real-world setting. Thank you for watching this video. If you are interested in our work, please come to our live session.